Everyone. And welcome back to the professional track of AI Tech North 2020. We're heading into our final session of the day. And as I promised at the start of the sessions, right yesterday, we've been going on a journey. So now we're going to be talking about AI for the future. Now, our first speaker for the day, we have David Burden, who is CEO of Daden Limited, here to discuss enriching virtual humans through Semantic web. Please welcome David.
Hi, good afternoon, and thank you. Yes, I want to talk to you about the work we've been doing around virtual humans, and particularly how we've been applying semantic web and knowledge graph technology. We've been involved in conversational AI for 15 years or so as a company, and I've been personally involved in writing chatbots for something like 20 years. And so what I want to do is sort of pull together some of the strands of what we've been doing. Talk first of all about what we mean by virtual human, then about the semantic web and some of the related standards and some of the heritage where that sort of technology has come from. Some of the tools out there for knowledge graphs, apologies for the typo, and then describe how we've been using those technologies on a couple of recent projects and some of the implications for the future design of chatbots and AI development. So the first question is what do we mean by virtual human? And needless to say, everybody has sort of their own definition of what that is. Sometimes they're being talked about as digital humans. Certainly in the keynote this morning, that was the phrase that was being used. And as you'll see from these, some of these are technologies which are here and now. A lot of them are media representations of what a virtual human might be like. But for me, it's about trying to create a computer application that has some semblance of being human. And that's not just in how it looks. It's also in how it converses, how it interacts, and how it behaves. So it's trying to be a little bit more sort of precise about what we're talking about. We found this graph has been quite useful. And what we've got on the bottom axis is the complexity of the technology that's driving the virtual human or driving the system. And from sort of relatively simple algorithms to more complex algorithms such as machine learning type technologies, and then potentially in the future into things like artificial general intelligence, and possibly one day into things like artificial sentience. But then up the other dimension, we've got actually how this application is presenting itself. So is it presenting itself just as a computer application? It's a spreadsheet, it's a word processor. Or is it trying to present itself as something that's very human? And on the right-hand side there, you've got sort of the domain of science fiction AI. Things like Cylons and replicants, C3PO, Skynet, HAL, all those sorts of things we sort of know and love. And then there's quite a big gulf between that and where we are at the moment, and what you might term marketing AI, with systems which are reliant on complex algorithms, but nowhere near as complex as might be required to get to the level that we talk about when we talk about science fiction AI. And as you see from where we operate principally, is with relatively complex algorithms, but we're certainly not dealing with the most advanced algorithms. We're actually often quite using relatively simple algorithms. What we're interested in, though, is how much we can do with those algorithms in order to create things which seem relatively human. And the second thing this chart gives us is quite a nice sort of set of challenges, which if we're thinking about creating a virtual human, what the sort of the challenges are going forwards. The first challenge is a relatively serious one, but it's probably achievable. And it's about sort of crossing this thing called uncanny valley, so creating bots that actually look and sound human, creating some sense of emotionality into them, so they're not just reading stuff in a very mechanical voice. And also actual natural language generation. We think natural language understanding, there's a lot of attention being paid to that. There's nowhere near as much attention being paid to natural language generation, even with things like GPT algorithms and the like around. But it's a big step from that challenge to a second challenge of actually how do we move from machine learning, neural network type approaches to a proper artificial general intelligence, to something that's a general purpose problem solving machine, where you can actually just give it a problem or train it and teach it how to do something. And that same software could then be taught to do multiple different tasks in the same way that you might train a human. And the third challenge is the one that we don't know if we'll ever actually achieve, which is actually what is it when that artificial general intelligence moves away from being a machine to being something that's got some level of sentience, some level of self-purpose and self-awareness. And one of the ways that we often characterize this is in terms of imagining it with its own internal dialogue. and having its own conversations with itself, its own dreams, its own goals, and how it actually thinks about itself and its life. So we found this been a useful sort of matrix to use to get us to think around what we mean by virtual human and what some of the challenges are that we might be facing in the future. And a lot of the work that we did probably started about 5 years ago when we did a project actually for Ministry of Defence and for DSTL, who was speaking earlier, around the concept of virtual humans. And we enjoyed the project so much, we turned the literature review, we used the literature review to actually develop a book. So we actually ended up with quite a nice book on virtual humans, looking at all the underlying technologies which are mapped out by that diagram, and really assessing the state of the art on each of those technologies, and then going on in the second half to think more broadly about some of the impacts that such virtual humans might have in different areas such as education, thinking about some of the ethical issues, and also looking at areas around digital immortality, which I'll touch on later on. So coming down a little bit more down to earth, when we talk about the semantic web, it has its roots in a paper written by Tim Berners-Lee. And it's the idea that everything in the world would have a unique identifier, a URI, and that you would be able to relate things to other things. And you would then have what are called ontologies to actually provide structure to those relationships, providing classes of things and superclasses of things. And that then software programs would then be agents that can actually interact with that knowledge graph, that web of information that's been created, and actually reason against it. So we're not talking about a web that consists of web pages. We're talking about a graph or a network that consists of things that exist, or things that you might want to talk about or reason about. And just to sort of explain that sort of quite simply, at the heart of the semantic web is this idea of a semantic triple, which is basically the atomic unit of knowledge or information. And that consists of three elements: a subject, so chair, sky, Daden, David Burden; a predicate or a relationship, sometimes called a verb, so made of, has color, has email, owns; and then either another object entity such as wood, or color blue, or an email address, or Daden, or it could actually be a property like a text or a date or a number. So the idea is that if we actually start to represent everything that we want to talk about through a conversational AI, or have an AI reason against, if we represent it as these triples, then what we begin to do, just by creating those different linkages between different things, is we start to create these knowledge graphs. And then from those knowledge graphs, we can then start to derive a lot of understanding of what is actually going on. And I'll talk about some of the ways in which we do that as we go through. And the semantic web didn't sort of appear out of nowhere. There is a lot of work, some of you probably from school days and university, the idea about concept maps and drawing it using diagrammatic approaches, mind map type approaches to connect things, connect causes and consequences together. And then a slightly more formalized version is something called topic maps, which around sort of the mid-2000s was quite popular, where again, topics are the things you're talking about, so they are the entities within that knowledge graph. The associations are then the relationship between those topics. And then the occurrences are typically actually the instances, so they are the precise examples of things, so David Burden being an example of a human being and so on. And so there's a lot of good sort of background work done to understand these sorts of ideas and to think about how we can use them to support human learning and human understanding. And what we're doing with the semantic web is really applying that to the machines and getting the machines to actually use these approaches. Needless to say, there's a whole bunch of standards out there to get your head around. Resource Descriptor Framework was the original one that defined the language for marking up triples and marking up the semantic triples. Quite honestly, it takes a while to get your head around it. It's not particularly human readable. It's obviously very rigorous. So what we tend to use on a day-to-day basis is something called TTL or Terse Triples Language, often abbreviated Turtle. And an example of Turtle is on the right-hand side there, where we've got a thing, the SS Canberra, and that thing is has a type of merchant ship. It's got a country of the United Kingdom. It's an instance of a cruise ship. It was operated by the Royal Navy for a while. It's named after something else. It's got a manufacturer. So we've got there a collection of the information about the Canberra expressed in triples forms through Turtle. And in fact, actually, that data has its origin in Wikidata. So actually to create that, we just had a script that used the Wikidata API. Wikidata provides its information in JSON linked data. So I had to do a bit of conversion to get it into the TTL format. But that's effectively an automated process. So it means potentially all of the triples which exist within Wikipedia, which is pretty much everything that's on the right-hand side of a Wikipedia page. Almost all of that information is available as triples for you to actually go and make use of within your own projects. And the other important language out there is OWL, the ontology web language, which actually defines how the classes and the subclasses work. Another key technology to get to grips with is something called SparkQL, and that's an SQL-like language to actually query these knowledge graphs and these triple spaces that you start to create. And as you see, if you're familiar with SQL, you can probably sort of make sense of what this SparkQL query is saying. It's looking to select a citing ID, a latitude and a longitude, and it's looking for a situation where something has an ID or something is a part of a task force, where it's a particular vessel, and it has particular sorts of armaments on it, and then extract out the latitude and longitude. And there are a number of other more proprietary approaches, but they're all based around similar sorts of ideas. And so actually you can create some quite complex queries to actually use against your triple space to extract information, and it going far beyond what you could do with a relational database approach. And why is this all important? And there's quite a number of interesting papers and articles that have been done over the last couple of years talking about how knowledge graphs provides a good counterpart to the machine learning approaches, and how actually if we really want to crack AI, we're not going to do that purely through a machine learning route, but actually using knowledge graphs to actually give some underpinning to the knowledge, to the understanding that the bot has, to be able to make a bit more sense of what it's doing and a bit more directionality to it, is quite important. So I certainly recommend you sort of have a look at some of the papers there to understand a bit more about how machine learning and knowledge graphs are very much things that should be running alongside each other, rather than things that are in competition, and that actually it's by using the two together is hopefully how we'll crack AI in the long term. And if you want a book on the subject, this is I think the best one we found over the last year, that actually explains the practicalities of what working with semantic knowledge graphs is all about, and explaining the sort of architecture that you might have. And the fact it's that bit in the middle, the light blue bit, the inference in the query engine, that's the piece where sort of all of the knowledge, if you like, or sorry, not all the knowledge, all the expertise resides, all the knowledge sits in the triple store. But it's that inference and query engine that's actually able to make the queries for you against that information, and then provide that back to your application in a sensible way. And you can see there you've got converters and scrapers that can actually populate that triple store from other applications, as I've said, from things like Wikipedia, Wikidata, and also ways of exchanging that data with bringing triples files from other sources. And that's the sort of overall architecture that you'd like to achieve. In terms of the tools that are out there that you can play with, and most of these you can certainly download, that they're either open source or there's free or community versions around, so you can download them and get going with them straight away. We started off with Apache, the Jena and Fezeki framework, which gives you a very basic way of storing and managing triples. But I think you fairly quickly find the limits of that, certainly we did. Protege is quite a powerful tool for desktop analysis. So it's not the sort of thing you'd write an application with, but if you've got a huge bunch of triples and you just want to run some queries against them, or you want to do some inferencing against them, Protege is a very good tool for that. The diagram top right is coming out of Protege. Neo4j is probably one of the most feature-rich systems out there. It is proprietary, although you can use RDF standards. They've got their own sort of in-house standards, which you're encouraged to use. But it does generate some really nice graphs, and it does scale to an incredible degree, and is probably the most robust of the ones we've looked at. You've also got things like Graken and BlazeGraph and JanusGraph out there as well, which are other tools that are worth exploring for building your own knowledge graph-based applications. And the sort of things to think about are the ease of getting data into these systems, the sort of visualization tools, because you're going to have tens, hundreds of thousands of triples in there, so you can't really understand what's in there just by looking at a tabular list. You really need something that will give you a good visual understanding of what's in there. This idea of asserted and inferred triples. So asserted triples are the ones that you create, but if the software has an ontology, it should then be able to understand which are inferred triples it can create based on the context it's got. And then it should have the ability to reason. So things like spatial reasoning, working out how far apart two particular entities might be at any particular time, or looking at things like social graph connectivity. So there's a number of factors there to think about when you're sort of selecting a social graph tool for a particular project. So just to talk briefly about a couple of the projects that we've been involved with and how we've been using these sorts of technologies. So the first one is around what we call virtual persona. And so that's looking at the idea about, can we take a person, can we create a virtual copy of them? When we started the project, we said we'll do it badly. We don't think the tools are out there to let you do it well, but only by doing it now do we get some understanding of where the gaps are and also what some of the ethical issues are that might come out of that. And so we used a conversational chatbot system called ChatScript, and then we used Yenya Fazeki to give us the database at the back end. We created classes for all the different sort of knowledge areas that this person would know about, and then populated the knowledge graph both through documented sources and also just through conversation with the subject. One of the most interesting aspects in terms of conversational AI, which I don't think we were expecting, is that most conversational AI systems tend to be question answer. But actually, by having the knowledge graph, it meant you could ask the persona a question about a particular topic. It would find the answer from the knowledge graph. But then if you just nod your head, the bot would then just find an adjacent triple on the knowledge graph and tell you that. And if you nod your head again, it would find another adjacent triple. And we could actually set parameters for how quickly it would drift from the topic you're originally asking about and moving on to different topics. And that's exactly the way that most human conversation tends to work. So we actually managed to replicate that sort of model of human conversation through using the knowledge graph. We also embedded it with anecdotes and episodic memory, so it could switch into a more narrative style. But the most interesting thing was by the end of the project, we actually built the bot so that actually you could sit down with an empty bot, and in about 35 hours of talking to the bot, you could begin to get a bot that had some semblance of the knowledge and the information that you have developed over your own life and your own career. The second project we've been doing, one of the big problems we had with the virtual persona is there are huge ethical issues, not least of which is what happens if that person dies, and who then owns the persona. So one way of sort of de-risking things going forward was instead to consider it as being the persona of a platform or of a project. And so it becomes an amalgam of information from different sources, some of which are related to the things that DSTL was talking about and they're talking about in parallel with Project Nelson at the moment. And so again, there we have the knowledge graph. We have the knowledge graph working with a conversational AI system. We're using Wikidata for some of the import. But the images there, just for interest, I mean, they're three different parts of the knowledge graph effectively. And it's interesting, you can just see by eye that they are different sorts of things. So the one at the bottom that looks quite chaotic is what's called the TLOs. That's the top level ontology. So that's its map of everything there is, if you like, and how all those things connect to each other. The very stylized one in the middle is actually based around sensor data. So that's about radar sightings of different ships, or AIS sightings of different ships, and where they've been and what they've been doing. And then the one top right, where you can see there's a sea of relative randomness and then 2 or 3 clusters. That's actually based around historical data. So each of those clusters effectively represents a story that the platform has about a particular instance. And so really just to finish off, for us, I think one of the key things about using knowledge graphs is that we're able to separate out the knowledge of the chatbot or the conversational AI from any of the linguistic elements that are needed to manage the conversation. And it lets us create a chatbot that gives us a far more human conversation rather than just a simple Q&A of a database. And you get this far more natural asymmetric conversation coming out of it. And I think it's important to note there are some really good work being done at the moment about looking at how we can take machine learning approaches and apply those both to actually analysing the knowledge graph, so as to identify some of the patterns I showed you on the previous slide. But also how actually we can get quite a good mapping between the sort of language you talk about in machine learning and NLP, so talking about entities and intents, and actually map those onto the components on the knowledge graph as well. And so with that, I'll finish. And if there's any questions, I'll be happy to take them at the end. Thank you.
Thank you very much, David. That was a great topic there that you described, and you delved quite deep into detail there. We're going to hand over straight to our next speakers for the AI for Future topics that we're going over here. Now we have Dr. Luis and Dr. Jose who are both lecturers in computer science and informatics at Cardiff University, here to discuss the power of natural language processing in social media. Handing over to you guys now. Thank you.
Hi, thanks for the introduction. So yeah, this talk is going to be the power of natural language processing, what we call NLP, in social media, no? And it's going to be presented by my colleague Luis and myself. I'm going to start, and then I'm going to pass over to him. So it's going to be a very high-level overview of some of our work that we do in this area. Our main research expertise is NLP, and lately we have been working quite a lot with social media. And the thing is, social media presents many challenges in the point of view of how we process language, because it has many different features that we don't find in usual text, like multilinguality we can find in many different languages, so even code switching, some extra linguistic features like emoji, that we need to process, and some words that they are changing, they are introducing new words, new vocabulary over time, and it is changing the meaning as well. So this is what we are going to talk about in this talk. First, just a small introduction. First, that we are working both in Cardiff University, where we created a group of in NLP, an interdisciplinary group, where our idea is to be a place for networking and to get to know people with different interests, but around language, how to process language. As well, and we are teaching in the master programs in Cardiff University, and a lot of that is interconnected with research as well, like applied machine learning, manipulating and exploiting data, and computational data science. That is also very relevant to the talk today. And just for you to get to know a bit about us, this is very short. Both of us, we are lecturing in computer science at Cardiff University, but we have a very different background. As I was saying also, that it's important for the field of NLP to have an interdisciplinary focus. That Luis is a linguist, and myself, I study mathematics, and now we ended up both in computer science, and we both has a PhD in NLP, and with different experiences also with industry as well, for which we also collaborate a lot now, where we are working at Cardiff University. So that's about us, and now I'm going to get to the presentation. As I say, it's going to be mainly about natural language processing, or what we call NLP. So what is NLP first? So it's an area of artificial intelligence, one of the most trendy nowadays, because it also has a lot of interest in industry, and basically because the data is growing, the data in internet, the data everywhere, and one of the most difficult things for AI is how to handle language. For us humans, we can communicate and talk it now, and you can understand what I'm saying, but for computers to understand language is much more complicated, and that's basically what we do. And as well, it's also very relevant nowadays because it's translated into many different applications, like machine translation, spell checkers, like many things we use basically nowadays. And then a lot of also applications that can be more relevant also with social media, like sentiment analysis, hate speech monitoring, fake news detection. All that are very relevant, and you need tools that are able to handle social media, like platforms like Twitter or Snapchat or Facebook or things like that. So first, how NLP works. So this is very reduced, very simplified, but basically we need data. So and that's not a problem nowadays because, as I was mentioning, it's growing over time. But there are two types of data. First is structure, and then organic, what we can find on the web, where things are not that structured. So what it looks like? So the structured data is similar to the talk before. It's like knowledge graphs. You can find in Wikipedia, Wikidata, other more domain specific, like in health, SNOMED, and things like that, where you have a lot of information in a structured manner. But that's often not enough, and we need actually more data, and most of the algorithms nowadays in NLP needs a vast amount of data that we can find on the web, like in social media, but also internet, and any kind of places where you can find a human language. So what is the goal that we have? So ideally what we do is combine these two sources of data, more structured and also unstructured, to build intelligent agents, no, like applications based on artificial intelligence where we can analyze text, or maybe things like a chatbot where you can interact with users, no, and things like that, where automatic models are actually the interface, no, with language. Basically, more concretely, our goal, what we do at Cardiff University, is language understanding. What we want is not only like we can solve applications, and nowadays it works very well, but we want also the algorithms to really understand language, and not only to exploit patterns or artifacts in the data, no, or maybe just simply biases, no, that you can find in the data, and because of that, maybe you are solving some particular issue. No, we want like we as humans, we understand language, and we want actually to have something similar with computers, and this is still quite far, no, quite far away. But that's why it needs a lot of research, and it has been a lot of progress nowadays. And the progress has been driven mainly by machine learning, and nowadays what we call deep learning or neural networks. That they are algorithms that they take data into account, and then they produce different applications. Like, for example, in sentiment analysis, we have a sentence, wait for the video and don't rent it. We need to say if that is a positive review or a negative, no? So for us, clearly we see it's a negative review. And how it works. So first, each of the words, there are different ways to represent, but this is one of the common ones. This is represented just as a vector, so it can be translated so computers can work with that. And then you have different algorithms, as I say, machine learning and so on, that process it. And we are mostly interested in this part of representation, no? Where our work it is not on the part of the algorithm itself of machine learning, but more of how we represent language and how it works. So one common way, as I mentioned, is to represent words as vectors in a vector, and then we have all the words in the vector space. And here, similar words are going to be clustered together. Like, for example, the big cats here, like we have cheetah, tiger, jaguar, panther, leopard, no? And if they are close in the vector space, then the algorithms can infer, no, that many things that are relevant to tiger is going to be also relevant to jaguar and animals like that, because they are both animals, they are both, I mean, they're from a similar family, and they share a lot of features, no. And this is something that as humans we know, but computers also, they need to understand these kind of things, no, in order to process. So I'm not going to get also into much details, but also recently we've written also a book on this topic that is going to be released soon, but otherwise there's also a free a draft freely available online. Yeah, and as I said, I'm not going to get into the details of how these embeddings work. As what we are interested in this social media aspect, and this is what to present by Luis, but first I'm going to just introduce, no, like social media is really a resource where you can find a lot of information about users and human behavior. And so there are many applications that you can do there, but the problem, as I mentioned, is like there is a vast amount of data, and you need some automatic tool, no, to help process this. And then you have many challenges, and as I said, multilingual, social media is in many different languages, so we want some models that can work in several languages simultaneously. Some extra linguistic features like emoji that we need to process, that is something that we don't find in a standard text, but it's very relevant in social media. And things like meaning shift, like meanings like people are introducing new words or words that already exist with different meanings. And this is so difficult for automatic models to keep track. And now I'm going to pass it to Luis, who is going to actually present all these topics in more detail. Thank you.
Thank you very much, Jose. Okay, so hi everyone. My second, well, the part of the presentation where I'm taking over is going to be the multilinguality, social media processing, and meaning shift. So let's have a look at the multilinguality part first, and why it's an interesting challenge to address in social media processing. So we know social media, right? So although most of the data in social media platforms like Twitter, Facebook, and others is in English, it's not the only language. And even if the distribution of English data is much higher than all the other languages combined, or could be, there are certain, it would be desirable, right, to have to develop technologies that work as well for English as for the others, or in NLP terms, resource-rich languages for which you have a lot of annotated data, a lot of resources, and a lot of interest from large, big players in the field. Ideally, you would like to have a way to have technologies that work in the same way for other languages. So this is a challenge, but it's also an opportunity, and we'll see a little bit about this later on. For example, how can we exploit the fact that we use emoji in social media for building better language technologies on top of social media data? Let's take, for example, think of an autocomplete or a spell checker for the English language, right? So you would write some piece of text in English, and your application on the phone or your correct spell checker on your writing assistant, they can give you suggestions how to improve the writing here, how to correct a mistake there. What if we have something like this for social media, but specifically working for emoji? Right, so emoji are used in a myriad of ways. Sometimes they're used as boosters for our own feelings, so to show that we're actually very angry or very happy, to signal irony as a way to explicitly mention something about the topic. Right, I'm going on holidays, and then you put a palm tree. So we've been doing some research on the task of emoji prediction. So given a piece of text, predicting the most likely emoji that would go with that text. And as we can see in this slide, the use of emoji sometimes is used also to express the inner workings, of the brain of the person tweeting. In this case, Roger Federer, has this doubtful emoji being used. And we have verified that it's actually possible to predict emoji. And we are interested in using emoji for building systems that would read tweets, and using the potential predictability of an emoji that could go well with that message, have a better signal to understand better what that tweet is about. And as I said, we should probably think of it at a high level in the same way as an autocomplete system, but it does enable a lot of studies on network dynamics and certainly the development of better NLP applications. But it's also, and that's something a relatively recent area that we've been working on using emoji as anchor between languages. Right, so if you look at all these tweets that congratulate a Spanish sportsman for his birthday, they are in different languages, but they do share one thing, and it's the cake emoji. Now, what we are interested in is to take advantage of the fact that there's this shared pseudo vocabulary, so that we can map whatever technology we have in one language to another language, because both languages have some shared vocabulary. Not a lot, but hopefully enough. And this is what we call cross-lingual transfer. Effectively, this is an area of NLP where we look at building applications in a language for which we have a lot of data, and we transfer that for under-resourced languages. So in practice, it's almost any other language. The typical pipeline for machine learning is to have some training data in one language, where you train maybe a sentiment analysis system or a document classification system on some data in one language, and you evaluate it or apply it on data in the same language. In cross-lingual transfer, you have the same training setting, but the testing setting is in a different language. And then the challenge is, how do I map maybe the Spanish language and the English language, or the Welsh language and the English language, into some shared computational representation, such that the English information, the English knowledge I have, can be applied to the target domain, Spanish, Welsh, German, etc. So at a high level, Jose spoke about these word vector representations. What we have is one vector space for English, one vector space for Spanish. So what we want to have is a mapped space where if a computer reads house, it should know that that's similar to casa, for example, which is house in Spanish. How do we map these spaces? Comes with anchors, so shared vocabularies. Usually, the classic way of do that would be to use bilingual dictionaries, but actually for social media, we can use emoji because, as I said, they constitute shared vocabulary. So the machine learning pipeline all of a sudden becomes take Twitter data in English, train your models in shared representation in a shared space with other target languages, run them there, and hopefully you get the same results or results which are close to a situation, a scenario where you would actually have a lot of the training data for sentiment analysis or for document classification or whatever in the target language. We have published a few papers on this, and we have, so these guys here are the results for cross-lingual sentiment analysis for a number of languages, and our results, well, they clearly verify that at least in the setting that we operate with, were better than existing state-of-the-art methods for cross-lingual alignment because of the method and because of the usage of social media-specific signals like emoji and so on. As byproduct of this is that you could induce a slang dictionary because you could take some words that are newly used or which you would never find in a dictionary and have a representation which also would have similar meanings for other languages. And this is very useful if you want, for example, to monitor how people are reacting in social media, if you can actually understand the words they use, which are never going to be in a standard vocabulary, in a standard dictionary, etc. Same with, this is another example, and so on. And before we finish, I just wanted to say a couple of words about an ongoing project that we have in collaboration with Snapchat. And the idea is the following. As Jose said, meaning shift. Words change in meaning over time, and even over time, some words actually are coined into the vocabulary. There was a very interesting paper from 2016 where they looked at longitudinal data, historical data, and looked at, similar words across different decades for a number of target words. And they could verify that indeed some words actually change meaning. And the way you could measure that was to look at how the similar words changed from one decade to another. No? And we have the example here, for example, of broadcast, which had the agricultural sense in the second half of the 19th century, whereas of course it got the media meaning in the 20th century. Now, in social media, this phenomenon is much more pronounced. And the reason is because social media is a rapidly changing environment. So some meanings actually change in a matter of months or even weeks. You can imagine, no? Let's say you have a way to monitor how often people are using the emoji of the volleyball, and you have a regular frequency, so nothing special happening with volleyball, but maybe you have a spike here. So people are, this is becoming trendy. But maybe there's a volleyball event, no? So that makes sense. But what happened here? There was no volleyball event, but there was a spike. So actually, you look at the news, and what happened was that Tom Hanks and his wife tested positive while being in Australia. So people started to correlate their situation with the movie where Tom Hanks was also left alone in an island, and the only friend he has was this Wilson character that he made up, painted on a volleyball. And actually, people started to use the volleyball emoji with a different meaning. So if you want to understand how people are reacting in social media, you need to account for these meaning shifts. And this can happen, as I say, in a matter of days and weeks. Another example is the use of the word Karen, which at the onset of the Black Lives Matter became a word to refer to, well, a prototypical white female in her 40s, 50s with racist attitudes. And this is something that happens a lot, no? And sometimes these new meanings stick. sometimes they don't. But if you have a classifier or a trend prediction model or a clustering algorithm or a recommender system based on data from social media, it's good to have a way to know how often words change in meaning, because this will tell you how often you should retrain your models. So, and this is a current collaboration that we have just kicked off with Snapchat, because of course this is an interesting area of research for both for industry and for academia. And as you can see here, certainly there's no event related to this word, but this word effectively changed this meaning. Right. So this has been a fairly quick overview of how social media and natural language processing kind of synergize. No, we hope you enjoyed some of the bits here and there that we provided. Long story short, social media understanding is a very cool technological problem. It's a very important social problem to look at, especially when it comes to multilinguality, because this is very far from being a solved problem. And actually, working on building good models for the meaning of words is helpful for understanding and developing real-world NLP challenges, and not only stuff that stays in a paper and never manages not to cross the knowledge transfer bridge. So that was more or less it. Yeah, it was a pleasure to participate, and I think we are ready to take questions. If yep.
Awesome, thank you. That was a great talk there. Thank you for delving deep into the whole social media aspect there. We'll jump straight into the Q&A here. So Jose and Louise, we have the first question here. Talking about how you explained using European languages, are there different challenges based upon if you're using non-European languages, stuff like Mandarin, Cantonese, Japanese, just because the structure of the language and the symbols and everything are slightly different? Are there any different challenges there?
Yes.
Jose, if you want.
Yeah. Oh, yes. Yeah. Yeah, definitely. I mean, the performance. When you have closest language, all this technology usually works much better, no? But when you have languages that are more difficult, and that's basically what our research is about, no? To try to improve for these cases that are more complicated, when you have different alphabets, different syntax, no, different things like that. Obviously, these automatic models struggle more, but they are improving over time. And I can say that you can use them also for these kind of languages, but always with be more careful that when you have, for example, European languages, they are quite close, they are all Romance language, and this technology usually works much better there. So definitely there are many challenges in terms of syntax, alphabet, and things like that they are not solved. They can be used, but they need a lot of improvement. Yeah.
Awesome. So we're still developing that technology there. Thank you for that. And if both of you had to summarize everything you've spoken about today down to three key main things that you want the listeners to take away from this, what would that be?
I'm sorry. Could you? I think I lost you for a minute. Is it okay to repeat? Yeah.
No, that's okay. If so, for Jose and Louise, if you had to summarize your whole talk into three key main points for the viewers, what would that be?
Okay. Well, it's social media. No, it's a gold mine. So we encourage people doing research in language technologies to look at social media data, because they are the best reflection of the language use at that point. Obviously, we are strong advocates of researching emoji. We believe this middle ground between an image and a word is a very good indicator sometimes of what actually people are meaning, and there's certainly not enough research out there to determine what is the best model for emoji understanding. And the third one would be meaning shift. No, so there's growing evidence that the meaning of words in social media changes in a matter of days. So if you're having in your organization, if you're relying on models trained on social media data, if you're not aware of these models that were trained, maybe a text classifier or a recommendation system that was trained 1 month ago with data from 1 month ago, is probably not going to be as good today, especially if something major happened where the distribution of tweets or the distribution of Facebook posts was dominated by this event. We have the example of the pandemic here, where most organizations had to retrain their models when people started to speak almost exclusively about COVID-19.
I will maybe just quickly, to finish and follow up with that meaning shift area. What I say also that social media is very challenging. So there is a lot of research in NLP, but most of the tools that works now with standard language doesn't work with social media. And that's why it's also important to do this research in social media, because you need to be able to address this challenging nature of social media. And yeah, that's that.
Awesome. Thank you for them answers there. The next question we have is for David. How do you handle unique IDs and URI when drawing data together from different data sources?
Yeah, I mean, need to say nobody's yet standardized what these URIs are, or even within their format. So what we typically do is we run some code against the incoming data so as to understand sort of what the current format is for the IDs. And then really we want to establish a mapping between that and our in-house format. But sometimes, I'm taking Wiki as an example, Wikidata, their internal ID format is just an alphanumeric. So you lose any human readability to it, which from a development point of view is an absolute nightmare. So actually what we did is our import script, rather than actually targeting their ID, we actually used some of the other fields within the data to actually generate the IDs that we used internally. But what we always do is we bring across the original ID, and we basically treat that as an object. So we have a predicate of Wikidata ID, and then an object of what that ID was. We've always got that link back to the original data set if ever we actually need to go and drill into that data set as well.
Awesome, thank you there. And again, same question for you here. If you had to summarize your whole talk into 3 key main points for the viewer, what would they be?
The first one is that artificial intelligence isn't only about machine learning. It does tend to sometimes seem that's all it's about. The second one is that we think knowledge graphs are an absolutely vital part of sort of how we move forward in terms of developing AI type systems. And the third one is that knowledge graphs gives us a way of thinking about information in the way that we tend to think about it in the brain, if you like. And so when we think about how that might manifest itself inside a computer system, it's that much more understandable and that much more explainable than some neural net-based approaches.
Awesome. Okay, I'd like to say thank you, David, for joining us. Thank you, Luis and Jose for joining us for this AI for the Future session. That's all we have time for in this session. And in fact, that is the end of the professional track for AI 2020 North, the Northern Summit AI 2020. I hope you've had a great time here. My name is Iti Nayaz, and I've been your presenter for today. And on behalf of the whole AI Tech North team and myself, thank you for joining us in the professional track. Thank you again to the speakers, and bye-bye.
Thank you. Thanks to you. Yeah.
Thank you, guys.
Bye.
Take care.
Yeah.
Bye.